Let us see the problem number 68. 2 point charges given. One is A and another is B. So Q1 is placed at A and Q2 is placed at B, but both of them having equal charges, plus Q and minus Q. Plus Q is placed at A and minus Q placed at B. D is the distance between two charges. So the force which is acting between them, K into Q1 Q2 by D square. D is the distance between them. And from this, and substitute the Q1 Q2 values, we get Q square by D square. Yeah, this is equation number 1. And now next, case 2. From above case, 25% of the charge A is transferred to the B. So that 25% means 25 by 100. We get 1 by 4 it is. 1 by 4 of the charge is removed from A and transferred to B. So that Q equal to Q minus 25% of charge is removed. Then we get Q minus 1 Q by 4. So from this, after LCM we get 3Q by 4 we get. And next here, after removing the charge, see, at A and B, what is the charge at A? Q1 equal to 3Q by 4. And charge at B equal to 3Q by 4. Now, the distance between the two charges are remain same. So we have to find out the electrostatic force between two charges. F dash, new force. F dash equal to K into the Q1, Q2 by D square. Now in this formula, let us substitute the Q1 and Q2. So Q1 3Q by 4, Q2 3Q by 4. After removing of a 25% of charge, we get so D square. Then 9 into 9, 3 into 3 9 and 4 into 4 16 and K into Q square by D square. Now here 9 by 16 into F, and if you look at the problem and from this, and this is an answer. 9F by 16. Next, problem number 69. Let us consider two infinite line of charges. They are arranged parallel to each other. Let us consider positive charge, linear charge density on one plate, which is distributed on both sides, that is represented by plus lambda, and negative charge is distributed another infinite line that is a negative charge, linear charge density, that is a minus lambda. Here 2r is the distance between two parallel infinite line of charges. Let us consider the center point, that is represented by O. At O we have to find out the total electrical field. So we are given the names A and B. So due to charge on A, electrical field at O, EA, that is towards the right side. And next electrical field due to charge on B, then that is vector EB towards the charge. So here if you observe, electrical field due to positive charge, it is away. Electrical field due to negative charge towards the charge. So now how many electrical fields are there? There are two electrical fields. So then we have to find out the electrical field due to individual line of charges. So now let us find out the electrical field due to charge on A. So vector EA is equal to lambda by 2 pi epsilon naught into R. Here R is the distance between the line of charge and point O. And next R is the distance between O to B. So now electrical field due to charge on B, vector EB equal to lambda by 2 pi epsilon naught into R. R is the distance between the point and the line of charge. Next here there are two electrical fields, and we find out the total electrical field at O. So the total electrical field vector E is equal to vector EA plus vector EB. Both are acting in the same direction. Then let us substitute their formulas. So lambda by 2 pi epsilon naught R plus lambda by 2 pi epsilon naught into R. Now after taking the LCM, denominator is same, so that lambda plus lambda 2 lambda by 2 pi epsilon naught into R. 2 to get cancelled, lambda by pi epsilon naught into R is the answer. Here next, let us see. So let us consider closed surface, but it is looking like a sphere. It must be sphere, and in the closed surface there is a dipole which has a negative charge, positive charge, both are separated by distance 2a. Here we are to find out the electrical flux which is passing through closed surface. Electrical flux is equal to question mark. Let us find out the electrical flux through closed surface. Flux formula: charge enclosed by epsilon naught. But what is the charge which is closed in the closed surface? Sum of all the charges in the closed surface, minus q and plus q, divided by epsilon naught. Then what is the total charge? 0. 0 by epsilon naught. 0 by epsilon naught is nothing but 0. So the total flux passes through the closed surface due to dipole is 0. Next, let us see the 71 problem. Let us consider electrical dipole which has a positive charge and negative charge, and O is the center of the dipole, and both are separated by a distance 2a. Let us draw an equatorial line. On the equatorial line, let us consider a point P. At point P, the electrical field should be found due to electrical dipole. So the electrical field at P, vector E, is equal to 1 by 4 pi epsilon naught into vector P divided by R cube. R is the distance between O to P. This is a formula. Next, the problem number 73. Let us consider a spherical conductor. O is the center of the spherical conductor, R is the radius, and its value is given 10 centimeters. Convert, and next, plus q is a charge which is on the surface, which is distributed uniformly, and its value is given 3.2 into 10 to the power of minus 7. Let us consider a point P, which is at a distance r equal to 15 centimeters. Centimeters convert into meters, we get 15 into 10 to the power of minus 2 meters. We have to find out the electrical field at P. Let's see how to find out electrical field at P. The electrical field at P, formula 1 by 4 pi epsilon naught into the Q divided by distance between 1 and P, so R square. So 9 into 10 to the power of 9 into charge value substitute 3 into 10 to the power of 3.2 into 10 to the power of minus 7 divided by R value 15 into 10 to the power of minus 2 whole square. Then we get 1.28 into 10 to the power of 5, the Newton by coulombs. Next, problem number 72. Electron and proton both are separated by certain distance r equal to 1.6 angstroms, and here r equal to 1.6 angstroms, we write 1.6 into 10 to the power of minus 10 meters. Here we have to find out the charge q1. Q1 equal to 1 electron and q2 equal to 1 proton plus 1e minus 1e q1. So next, the force between the electron and proton, F equal to question mark. F equal to 1 by 4 pi epsilon naught into the q1, q2 by distance between them, r square. So 9 into 10 to the power of 9, its value, into q1 value 1 electron plus and q2 minus e divided by r square. So if you observe here and let us substitute their values, the plus e is the charge of proton and minus the charge of electron. So plus into minus minus. If the minus indicates the force is attractive. Force is attractive. And here let us substitute the e square, e values, and now it is e square, e into e square divided by r square. And now minus 9 into 10 to the power of 9 into substitute e value, charge of electron and proton, 1.6 into 10 to the power of minus 19 divided over the whole square divided by what is r value, so 1.6 into 10 to the power of minus 10 whole square. Then after minus 9 into 10 to the power of 9 into the 1.6, we write whole square into 10 to the power of minus 38 divided by 1.6 whole square into 10 to the power of minus 20. Here cancel the same things on numerator and denominator. We get minus 9 into 10 to the power of 9 into 10 to the power of minus 38 into 10 to the power of plus 20. If you bring it up, then now minus 9 into 10 to the power of 9 overall, so we get minus 9. So here that is a F value. Now acceleration of electron must be find out. Acceleration formula, force by mass of electron. So then substitute the force value, 9 into 10 to the power of minus 9, magnitude value only, divided by mass of electron, 9.1 into 10 to the power of minus 31 kg. So then after calculating, we get 10 to the power of 22.